Hi everybody, today's lesson is about finding out what is the impedance in an RL series circuit. So just to explaining the meaning of just the heading is the word impedance is the total current limiting effect that the components of a circuit have. And why do we need to know that? Because in order to calculate the current, we need to know what is the supply voltage and the total current limiting effect. And for the resistor, you have resistance, and for the inductor, you have reactance. And the voltage across the resistor at any point in time is given by Ohm's law. VR equals IR, and the voltage across the inductor is given by IXL, where I is the circuit current, and the voltage across the supply is given by IZ, where Z is the total current limiting effect, and that's called impedance. Now, Z, XL, and R, the impedance, reactance, and resistance are all measured in ohms. Now, we have learned that the voltage across the inductor and the voltage across the resistor are out of phase in an AC circuit, and they're out of phase by 90 degrees, with the voltage across the inductor leading the voltage across the resistor. So knowing that, we can draw a voltage phasor diagram. So now, for a voltage phasor diagram, it is customary to draw the voltage across the resistor as the horizontal vector. Okay, so phasors are rotating radius vectors. The voltage across the inductor is given as VL, which is 90 degrees ahead of the voltage across the resistor. Phasors, we just say they go anti-clockwise. Okay, so that leads, that one lags. And how do we get the supply voltage? So that's done by completing this parallelogram. So you're drawing parallel lines, and the diagonal gives you the supply voltage. So looking at this and applying Pythagoras theorem, we can get Vs squared equals Vr squared plus Vl squared. Now if you substitute Vs, Vr and Vl with Iz, Ir and Ixl, then our equation becomes Iz squared equals Ir squared plus IXL squared. I is a common factor, so you end up with Z squared equals R squared plus XL squared, or square rooting everything. Z is equal to R squared plus XL squared and square root of that. So that's how you find out or calculate the impedance of an RL series circuit. Now, knowing this, we can draw what's called an impedance phasor diagram. So we never mix up vectors while drawing these, so we keep them all the same quantity, but it's very similar to the voltage phasor diagram. So instead of VR, we're just going to put R, which is resistance, and instead of VL, we're just going to put XL, which is reactance, and instead of VS, which we get by completing this parallelogram, we're just going to get Z, which is impedance, and Z leads R by theta degrees, and Vs leads Vr by theta degrees. These angles will be the same, and Vs, because the current is always in phase with the resistance voltage across the resistor, we can say Vs leads the circuit current by whatever this angle is. Okay, and just one last thing, how do you get XL, which is the reactance of the inductor? XL is given by 2 pi FL, where F is the frequency of the supply and L is the inductance, which is a constant for an inductor. In your formula sheet, you might just see XL is omega L, and you will find omega is 2 pi F. So you got to combine these two in order to get that. So this is how it's on the formula sheet. So just putting these two together and you're going to get that. Okay, bye for now.